We've dealt with the camera control now. It doesn't matter where our player goes, our camera will follow. What we want to do now is correct our player's rotation so that he changes speed relative to our character movement speed. So let's pop the player code open here and look for our rotation code. Here we are. So what we did was, as we are pressing a button or holding any analog input or magnitude is larger than 0, we have our rotation calculation, which decides which direction we're going in terms of pressing the keys or moving the analog stick, and then we lerp our character into that direction, multiplied by turn speed. And that's the important part, turn speed. What we want to do now is decide what's our lowest speed and what's our highest speed. Our highest speed is what we turn by when we're not moving. Our lowest speed is the maximum amount that we turn by when we are moving. So, duplicate this and set now turn speed low, and we want another duplicate, turn speed high. Let's set these nicely. So what we have right now is set to 5. It feels a little bit slow, especially when you're not moving very quickly. So the lowest turn speed we want is essentially 5. The highest turn speed we want, let's go 4 times that, 20. Nice, quite high. So what we want to do now is set our turn speed relative to those two, of course based on our actual speed, our movement speed here. So velocity, which is of course a vector 3, and this is something we're going to have to deal with as well. We're going to look at that and lerp our turn speed between these two values. So let's do that now. Before we do our rotation code here, we're going to have to calculate our turn speed. So turn speed equals. Now then, that's going to be a float, so we use the mathf lerp function, not the transform rotation quaternion lerp or the vector 3 lerp. Here we're using mathf because it's the float. In the brackets, close it up. So we're going to start with our low speed, turn speed. Actually, we don't want to start with the low speed, we want to start with the high speed. Okay, and then after the next comma, turn speed low, because as we're at low speed in actual movement, so our velocity is low, our turn speed is high, and as our velocity increases, our turn speed gets lower. So we do it like that, and now we essentially just use a variable which I'm going to call, let's see, TS. Very simple. Very simple. Right, so we're already doing the time.delta time. We could do that here, or we could do that there. So this decides now between 0 and 1 how far along we go from here to there. So if we look at our velocity now, so we want a float here which is TS, which I've just decided here, a nice temporary variable, equals velocity dot magnitude. So that tells us the current speed we are moving at. This is a vector 3, we'll deal with that later. We're not even doing vertical movement yet anyway. Velocity dot magnitude. As we know, our speed variable, which is set to 5, is the maximum speed we're ever going to move at anyway, because that's the amount we're going to lerp to in our velocity. So that 5 is the maximum we're going to lerp to. How do we get from 5 to 1? We just divide by 5. So let's divide our magnitude by 5. Now we know that regardless of our velocity, at top speed we're going to get a result of 1. At absolute 0 we're going to get a result of 0. So now we're blending between turn speed high and turn speed low within the range of 0 movement speed and our maximum movement speed. That will work perfectly already. Let's have a look. Switch back over to your game, press play, and watch this. As we turn, when we're not moving, you can see he very quickly turns his body. However, when we're moving, you get this nice slow lerpy feel to our rotation. And remember, I'm using a keyboard here. So look, instant turn, instant turn, instant turn. But as we're moving, slow, slow, slow turning. It's really cool. So now we have a lot more control as we're standing in one place just to move around. And of course, we can do this while rotating our camera as well. It feels like we have a lot more control now over our character just by changing his rotation. We didn't even change his movement code. We only changed his rotation speeds relative to our our movement speed, actual speed. Of course, he does look a little bit floaty, so we're going to change that as well. Switch back over to your game, and here when we do a lerp, we control it by acceleration. So we want to change our acceleration. Let's increase that to about 15. We had it at 8. Save it, switch back over, and that should complete our corrections. Now we have a pretty nice movement speed here. It feels like we have a lot of control over the character. He still feels nice and smooth. We can change our low turn speed if we want to, just to make him a little bit faster on the rotations. We can decrease our acceleration a little bit actually, because he feels a bit like he's moving instantly. So I'm going to do that now. We're going to increase our turn low speed to about, I don't know, let's say 7. We're going to decrease our acceleration down to about, let's say 11. Switch back over, and here he is with a really nice speedy moving character that moves nice and smoothly, and it works. It just works nice and neatly. And you can see now that he has a lot more control over his rotation even at full speed, because we increased the speed by a simple 2. So we went from 5 to 7. And when he stopped, he has full control over where he wants to go just by pressing that key. Nice and easy. Nice and easy. He still gets blocked by these objects here. Of course, we haven't dealt with gravity, so you can see he can just float around. But he has a lot of control over everything he does. That's this whole video. In the next one, what we're going to do is deal with gravity. We're going to apply gravity, and then we'll give him some jumps later on as well. What we're going to do before that is, of course, build a nice little simple level with a ramp so that we can test our movement in terms of verticality. Goodbye.